Hello everyone, welcome to MK Academic Solution. So this is D Chinnagokari, HOD of Chemistry in MK Academic Solutions. Okay. So in this video, I am going to explain you factors effect on rate of reaction. So this is the third video on the chemical kinetics chapter. Okay. So in this third video, I am going to explain you about the factors effect on rate of reaction. So what are the factors effect on rate of reaction? You will see. Okay. Right. So here we are going to discuss about the factors. Which are the factors effect on the rate of reaction and rate constant. Okay. Now let us see. So these are the there are several factors are there which affect on the rate of reaction. The first one is nature of reactants and products. Next concentration, next effect of temperature, effect of catalyst. These two are very important, and surface area, pH of the medium, and exposure to the radiation and electromagnetic effect. So these are the factors which affect on the rate of reaction and rate constant. Okay. Now let us go to the one by one in detail. The first one is nature of reactants and products. Okay. So what is the first topic here? Nature of reactants. Nature of reactants and products. Okay. So in the nature of reactants and products, we can see first physical state of the reactants. Physical state. The first one we can say physical state. Physical state. Okay. So physical state also going to influence the rate of reaction. So here generally we are having three physical states. They are solid, liquid and gas. Solid, liquid, gas. Solid, liquid, okay, solid, liquid and gas. Liquid and gas. Okay, these are the three physical states we are having. Okay, so out of these three physical states, gaseous reactions are very fast when you compare to the liquids and when you compare to the solids. See why the gaseous reactions are very fast here, children. So in gases, molecules are arranged very loosely and they are having high kinetic energy. They are having what? High kinetic energy. High kinetic energy. They can collide with one another with high speed and collision frequency is also more. Okay, high kinetic energy. Whereas in solids, how the molecules are arranged? The molecules are arranged very closely and they are having low kinetic energy and less number of collisions. So here we can observe more number of collisions, and here less number of collisions, less number of collisions. Okay. So there is a high probability of rate of reaction, there is low probability of reaction. Okay. This is the physical state. And also one more physical states we can take, that is homogeneous and heterogeneous. Homogeneous and heterogeneous. Okay, let us consider homogeneous reactions are very fast when you compare to the heterogeneous. Okay, homogeneous reactions are very fast when you compare to the heterogeneous. Why homogeneous reactions are very fast? What is the reason here behind it is there? In homogeneous reactions, the reactant species are mixed uniformly. The reactant species are mixed uniformly and there is a more probability of number of collisions. In heterogeneous mixtures or in a heterogeneous phase, what will happen? There is no thorough mixing of reactant species, so that there is a less probability of collisions. That is why homogeneous mixtures homogeneous phase will give more rate of reaction when you compare to the heterogeneous reactions. Okay. Next, chemical nature of reactants. Okay. Now we see the chemical nature. Chemical nature. Chemical nature. Chemical nature. So in chemical nature, mainly we can consider two types. The first one is covalent reactions and the second one is ionic reactions. So the first one is, we can take, let us take first one only, ionic reactions. See, ionic reactions are very fast, ionic reactions are very fast. Why ionic reactions are very fast? Because in ionic reactions there is no need of breaking of bond and making of bond. Simply what they will do, they will exchange their radicals. See, for example, here I am going to take AgNO3 silver nitrate aqua and NaCl aqua sodium chloride aqua I am going to take. Okay. So now it give a quick reaction of AgCl silver chloride precipitate here you will get and NaNO3 sodium nitrate aqua. So this reaction is very fast. Immediately this reaction is going to take place when you mix the silver nitrate and sodium chloride. Why? Because here silver nitrate exists as Ag+1 and NO3 -1. Means it is a simple attraction force. This ionic bond is formed by simply attraction force. And here Na plus and Cl minus. Here also this bond is formed by a simple attraction force. So what they are doing, they are simply exchanging their radicals. Means there is no need of breaking of bond and there is no need of making of bond. Simply what they are doing, they are exchanging their radicals and forming as Ag plus Cl minus and here Na plus and NO3 -1. Simply what they are doing, they are exchanging their radicals. That's why it's very fast reactions. Next, coming to the covalent reactions. Covalent are molecular. Covalent are molecular. Okay. Molecular. Reactions. Covalent or molecular reactions. Covalent or molecular reactions are very slow. Why they are very slow? Because here we need to break the bond and here we need to make the bond. For example, here you take the 2NO plus O2 is gives rise to 2NO2. So here NO, N double bond O, 2 molecules of N double bond O is there here, which means one molecule contain 2 bonds, 2 molecules contain 4 bonds. Means here in NO we need to make the 4 bonds and in oxygen O double bond O, here also 2 bonds are there. Total 4 plus 2, 6 bonds we need to break here. Total how many bonds we need to break, children? Here total 6 bonds we need to break. And here how many bonds are going to be formed here? 2NO, it is N double bond O and O. So here this also 2 molecules is present, means each molecule contain 3 bonds, 2 molecule contain what? 6 bonds. So here 6 bonds need to be formed. So this will take some time, means it will take some time duration. That's why covalent reactions are very slow and ionic reactions are very fast reactions. Okay. So this is about the nature of reactants and products. And one more thing also you can consider, that is stability. Stability of reactant increases, rate of reaction decreases. Stability of product increases, rate of reaction is increases. So here we can add that thing also, that is stability. stability of reactant. Stability of reactant is directly proportional to, stability of reactant is inversely proportional to rate. So reactant is more stable means rate of reaction is low, and stability of product is directly proportional to rate of reaction. Means product is more stable, the rate of reaction is more. If the stability of reactant is more, the rate of reaction is less. Okay, like that we can consider. Next one, what is the next factor which affect on the rate of reaction? That is concentration of reactant. Okay, so here concentration of reactant is directly proportional to, okay, concentration. So here concentration is directly proportional to rate of reaction. Here concentration increases, concentration of reactant increases, rate of reaction is also increases generally. Okay, see for example, so let us consider burning of wood. Burning of wood we can take in case of air, in case of only oxygen, in case of air and in case of only oxygen. We know air also contain what? Oxygen, but how much percentage? Only 21% of oxygen is present. In case of only oxygen, here 100% oxygen is present. Means here concentration of reactant is less and here concentration of reactant is more. In case of air, burning is slow process, burning of wood. In case of oxygen, only oxygen we are going to take, means 100% oxygen is present. Okay, here burning of oxygen is very fast. Okay, this is the effect of concentration, which means concentration increases, rate of reaction is also going to be increase. Okay, next another factor. So here what is the next factor here which affect on the rate of reaction? That is effect of temperature. After concentration we are having effect of temperature. So what about the effect of temperature here? Okay, so effect of temperature, we'll see. Effect of temperature. So generally temperature increases, rate of reaction and rate constant both increases. So temperature increases, rate of reaction, and rate constant, rate of reaction and rate constant, increases, rate of reaction and rate constant increases irrespective of the nature of reaction, whether it is exothermic reaction or endothermic reaction, irrespective of exo or endothermic reactions, exo or endothermic reactions, which means children, temperature increases, rate of exothermic reaction also increases, rate of endothermic reaction is also increases, and rate constant of exothermic reaction, rate constant of endothermic reaction is also increases. According to Arrhenius theory, for every 10 degree rise in temperature, according to Arrhenius, this is also called temperature coefficient. Okay, so temperature coefficient, according to this temperature coefficient, for every 10 degree rise in temperature, okay, for every 10 degree rise in temperature, okay, so what is the temperature coefficient is telling here, children, for every 10 degree rise in temperature, for every 10 degree rise in temperature, the rate of reaction increases, approximately 2 times, So this is known as what? Temperature coefficient. See, for example, this how we can write kT plus 10 degrees Celsius by kT, that is equal to approximately 2 times. So this is known as what? Temperature coefficient. Okay. So now let us discuss how the rate of reaction and the rate constant increases by increasing the temperature by graphically. So now see, so this is the graph plotted between the number of molecules with kinetic energy, means here this side what you have taken, okay, so this side we have taken number of molecules, so here we have taken number of molecules, okay, and here this side what we have taken, kinetic energy of molecules, okay. So here this is the temperature T1, it is the temperature T1 and it is the temperature T2. So here condition is what? T2 is greater than T1. So here we can see that here we have taken at 310 Kelvin, that is the temperature T2, this is the 300 Kelvin temperature T1. So when you observe this graph, okay, so as kinetic energy increases, the number of molecules also increases to up to a maximum, and then after they are going to decrease with kinetic energy. Means kinetic energy increases, what is happening, the number of molecules increases up to a certain value, this is known as what? Maximum, and then after what they are doing, the number of molecules are going to be decrease. Next temperature, now we raise the temperature at 310 Kelvin, 10 degrees we have raised. So then that time what will happen, again the number of molecules with maximum kinetic energy increases. Now we observe that the maximum shift towards more kinetic energy, this maximum shift towards what? More kinetic energy. So this is the more kinetic energy, and here we are having less kinetic energy, okay, more kinetic energy and less kinetic energy. Okay, more kinetic, less kinetic energy and more kinetic energy. Okay. Okay, right. Right, children. Okay. And so now what we are going to, this is, let us consider this is the activation energy. At this activation energy, how many molecules are crossed this barrier? See, in the at temperature T2, more number of molecules are crossing. This is the particles with energy at 310 Kelvin. So means these number of molecules are these number of molecules. Okay, you can assume here. So these number of molecules are crossing the energy barrier at activation energy at a temperature T2, and this blue colored one, this one is what? Particles with energy greater than activation energy at 300 Kelvin. Means what this graph is telling us very clearly. So at more temperature, more number of molecules are crossing the activation energy, and at less temperature, less number of molecules are crossing the activation energy. So which gives us information. So here what are the conclusions we can draw from this graph? At higher temperature, at higher temperature, more molecules crossing, more molecules are crossing activation energy, when compared to low temperature. So this is the reason why at high temperature the rate of reaction is more, and low temperature the rate of reaction is less. Okay, right, children. Now let us use the Arrhenius equation. To give clarity on the temperature. Okay, so what is Arrhenius equation? Means we are going to discuss Arrhenius equation at a different temperature. Okay, so what is Arrhenius equation here, children? Arrhenius equation, we know what is Arrhenius equation. K is equal to A into e power minus EA by RT. This is the Arrhenius equation. Now let us modify this Arrhenius equation as ln K is equal to ln A minus EA by RT. ln K is equal to ln A minus EA by RT. Therefore, at temperature T1, so at temperature T1 we are going to consider, at temperature T1 K is equal to K1. Okay, therefore what is the Arrhenius equation here? You will get ln K1 is equal to ln A. This Arrhenius pre-exponential factor is not going to change with respect to temperature. So now here activation energy also not going to change, R also not going to change, and temperature will become T1. So this is considered as equation number 1. At temperature T2, K is become equal to K2. So now we consider it as the equation number 2. So now condition is what? Temperature T1 is less than temperature T2, means T2 is greater than T1. Okay, now what I am going to do? Okay, so now let us do 2 minus 1, subtract the equation 1 from 2. Okay, so now when you do the 2 minus 1, what is the means? RHS you need to subtract, LHS you need to subtract. So that's why what we will get here, ln K2 minus ln K1 is equal to ln A minus EA by R T2 minus ln A minus EA by R T1, like that you will get. Okay. So now ln K2 minus ln K1, ln K2 by K1, ln K2 by K1, that equal to, so here ln A minus EA by R T2 minus into plus minus ln A minus into minus plus EA by R T1. Okay. So now here plus ln A minus ln A will get cancel out. Okay. So now what remains here, ln K2 by K1 is equal to EA by R T1 minus EA by R T2. Okay. This remains, right children. So now here EA by R you take common, ln K2 by K1 is equal to EA by R we are going to take common. So what you will get here, 1 by T1 minus 1 by T2, 1 by T1 minus 1 by T2. Okay. So this is what Arrhenius equation at different temperatures. Okay. So now this in place of ln we can write the log, that is 2.303 log base 10, or base 10 you no need to write also, no problem, K2 by K1, that is equal to EA by R. And here also some do take LCM here. So take LCM is T2 into, sorry, so when you take the LCM there, what you will get, T2 minus T1 by T1 into T2. So now you send this 2.303, that's it. So what you will get here, log K2 by K1 is equal to EA by 2.303 or T2 minus T1 by T1 into T2. Okay. So this is the Arrhenius equation at different temperatures. This is what Arrhenius equation at different temperatures. This is the effect of temperature on the rate of reaction. Okay. Next we will see the next factor. What is the next factor which affect on the rate of reaction? Catalyst. Okay. So catalyst. Now we are going to see about the catalyst. So catalyst, effect of catalyst. So what is catalyst? So what is catalyst, children? Catalyst means the substance which does not present in the reactants, does not present in the products, but it enters in the reaction to change the path or and change the speed of the reaction. That is known as what? Catalyst. Catalyst is a substance, the substance which alters the rate of reaction, which alters the rate of reaction, as well as rate constant, which alters the rate of reaction without consuming in the reaction. in the reaction. So here how a catalyst can affect the rate of reaction? How a catalyst can affect the rate of reaction means catalyst change the path of the reaction and also it changes the activation energy of the reaction. Catalyst changes the speed of reaction, changes the speed of reaction by the first one changing activation energy, changing activation energy and changing path of reaction, changing path of reaction, changing the path of reaction. So by these two ways a catalyst can alter the rate of reaction. By these two ways a catalyst can alter the rate of reaction. So now let us see the type of catalyst. Okay. So now let us see the type of catalyst. Okay. Type of catalyst. Type of catalyst. Okay. There are two type of catalysts are there. So type of catalyst you are going to take. So there are two type of catalysts are present. So that is the first one is positive catalyst. Positive catalyst and second one is negative catalyst. Negative catalyst. So what is a positive catalyst and what is a negative catalyst? So here first one positive catalyst, the catalyst which increases the rate of reaction, the catalyst which increases the rate of reaction, which increases the rate of reaction or speed of reaction, that is known as positive catalyst. Next to negative catalyst. Negative catalyst means the catalyst or else take the catalyst which increases the rate of reaction by decreasing activation energy, by decreasing activation energy, that is known as positive catalyst. And in negative catalyst, the catalyst which it decreases the rate of reaction, the catalyst which decreases the rate of reaction, which decreases the rate of reaction by increasing activation energy, by increasing activation energy. Okay. So these are the type of catalysts. Okay. Now let us see the graphical representation. Okay. Now go to this graphical representation here. So look at this, children, right. So now here we are going to take this graph potential. Okay. So here on this axis we are going to take the potential energy. Okay, on this is the y axis. Okay, here. Okay, this is the y axis and this is the x axis. On the x axis we are going to take the reaction coordinate, on the y axis we are going to take the potential energy. Okay, potential energy increases and reaction coordinate this side. So here let us assume this is what? Reactant. Here we are having the reactant and here we are having what? Product. Okay. So this is the path 1. This is the activation energy in the path 1 and more activation energy. Let us consider higher energy barrier for the reaction in absence of catalyst. In absence of catalyst. Okay. So here this is what? Lower energy. This is the second path, low energy barrier for the reaction in presence of catalyst. Okay. So when we are having presence of catalyst, so actually it is which catalyst? Positive catalyst. Positive. So here what the positive catalyst will do, children? It decreases the activation energy. So this is what? Activation energy in the presence of positive catalyst. This is the activation energy in the presence of in the absence of catalyst. Now you take one more path. Okay. You may consider like this. Okay. This will be the activation energy. So this is the activation energy in presence of negative catalyst. Negative catalyst. So negative catalyst increases the activation energy, positive catalyst decreases the activation energy. That's why when we are having a negative catalyst, rate of reaction is very slow. When we are having positive catalyst, rate of reaction is very fast. Okay, and in presence of normal rate of reaction, like that you can consider. Okay. So now let us take the Arrhenius equation. Let us take the Arrhenius equation and calculate the activation energy in presence of catalyst, means in presence of positive catalyst and without catalyst. Now let us take the two situations and let us see the what is Arrhenius equation. Okay, what is Arrhenius equation, children? We know that is. So here you keep one thing in mind, temperature is constant here. Temperature we are not at all going to change. So what is the Arrhenius equation? Arrhenius equation. So what is Arrhenius equation here? We know that is ln K is equal to ln A minus EA by RT. Okay, ln K is equal to ln A minus EA by RT. So now we take the two situations in presence of positive catalyst. Sometimes they will give simply catalyst. Catalyst means you just consider positive catalyst itself. So let us consider activation energy EA. Activation energy is equal to EA1. EA is equal to EA1 and K is equal to K1. Okay, and in presence of, so in this case what is the equation here? You will get ln K1 is equal to ln A minus EA1 by RT. Okay, and second case you consider in absence of catalyst. In absence in absence of catalyst. In absence of catalyst, activation energy EA is equal to EA2 and K is equal to K2. So now Arrhenius equation will become as children, ln K2 is equal to ln A minus EA2 by RT or T2. So here it is R. No. Temperature is constant in every case. This is also RT. This is also RT. Okay. So you consider it as the equation 1 and it as the equation number 2. Okay. So now let us calculate the activation energy difference. What is the activation energy difference? And when you know the activation energy difference, we can calculate the difference in between the K1 and K2 also we can calculate. Okay, right children. Now let us proceed here. So now take the equation 1. What is the equation 1? ln K1 is equal to ln A minus EA1 by RT. This is the equation 1, and ln K2 is equal to ln A minus EA2 by RT. This is the equation number 2. Okay. What is the equation number 1 and equation number 2 we have considered there? Equation number 1 is in presence of positive catalyst. Equation number 2 is in absence of catalyst. Okay. So here what are the conditions you will get here? Okay. So here activation energy 1 is less than activation energy 2. Why? Because it is presence of catalyst, positive catalyst. It is presence of what? Catalyst. It is absence of catalyst, means without catalyst. Okay children, right? Now here what about K1 and K2? Here K1 is greater than K2. K1 is greater than K2. Okay, why? Because in absence of catalyst more activation energy, less K value. In presence of catalyst less activation energy, more K1 value. Okay, now let us do again here also what you do, 2 minus 1. 2 minus 1 you do. Okay, when you do the 2 minus 1, what you will get? The same equation. Okay, 2 minus 1 means here ln K2 minus ln K1, that is equal to ln A minus EA by RT, EA2 by RT minus ln A minus EA1 by RT. Okay. So therefore ln K2 by K1 is equal to ln A minus EA2 by RT minus into plus minus ln A minus into minus plus EA1 by RT. Okay. So here also again plus ln A minus ln A will get cancelled out. Okay. Therefore ln K2 by K1 is equal to EA1 by RT1 minus EA2 by RT. So here T1 not there, temperature is constant, RT. Okay. So now ln K2 by K1 is equal to EA you take common, sorry RT you take common, 1 by RT, that is EA1 minus EA2. Okay, this is the equation you will get, or else 2.303 log K2 by K1 is equal to 1 by RT EA1 minus EA2, like that you will get. Right, or else log K2 by K1 is equal to 1 by 2.303 RT EA1 minus EA2. Okay, so these are the equations derivation. Okay, so this is about the effect of catalyst on the rate of reaction. Okay, next we will see what is the next factor, children. Surface area. Surface area. See here, surface area increases, rate of reaction is also increases. Okay, surface area increases. Surface area is directly proportional to rate of reaction, ROR. So how we can tell that? See, simply you take the wood again. Wood you make into pieces and without piece, means chips like you are making, small chips like this small pieces, taking a log, wooden log, and here we are going to make into small chips. So they catch fire easily. They catch fire easily. So this log will not catch fire easily. Will not catch fire easily. Will not catch fire easily. Why? Because here less surface area and here more surface area, it burns rapidly. And it will not burns rapidly. Okay, so that's the effect of surface area. Next, pH. So pH mainly important in the acid and base solutions. When we are having acids and bases, pH is going to give some effect on the rate of reaction and exposure to the radiation. The next factor is what? Exposure to radiation. So when this factor is important, when there is a effect of sunlight, for example photosynthesis reaction is there. Photosynthesis reaction is what? Light sensitive reaction. They occur in the presence of light only. When they get some optimum light, they will give high rate of reaction. And also H2 plus Cl2 combine in presence of sunlight only and it will give HCl. H2 plus Cl2 in presence of HN will give HCl, 2HCl. And photosynthesis. So all these are what? Light sensitive reactions. And next, effect of electromagnetic field. Effect of electromagnetic field. So this is important in case of polar solvents, polar substrates. When we are having polar substrates, then only we can imagine some effect of the electromagnetic field on the rate of reaction. Okay, so these are the total factors which affect on rate of reaction. Okay, what we discussed in this class, children? Now let's see what I have explained to you. I have explained to you the factors effect on the rate of reaction. Nature of reactants and products, we have discussed concentration, effect of temperature. So nature of reactants and products, physical state and chemical nature. And next we go to the concentration, concentration is directly proportional to the rate of reaction. So here you can take rate is directly proportional to concentration to the power n, or rate is directly proportional to pressure to the power n. Okay, right children, partial pressure, right. Next, I explained to you the effect of temperature, temperature, effect of temperature. After the concentration, effect of temperature increase, rate of reaction is also going to be increase irrespective of exo or endothermic reactions. Temperature coefficient, for every 10 degree rise in temperature, rate constant increases 2 times, like that. Next, we have the discussion on the graphs. I have explained about these graphs. And next, Arrhenius equation in the temperature variation. This is the Arrhenius equation. This is the important thing you need to remember. Next, catalyst, type of catalyst. So what is how the catalyst is going to change the rate of reaction? By decreasing the activation energy, like that. Then after, Arrhenius equation with presence of catalyst and without presence of catalyst. Okay. Next, the remaining factors, that is surface area and pH, exposure to the radiation, effect of electromagnetic field. Okay. So this is about the factors effect on the rate of reaction. Out of these, you need to learn properly effect of temperature, effect of catalyst. There only they asked some question in previous year. Okay. After completion of all the lectures, I will explain the previous year questions also. Okay. Thank you for watching.